Hello, a warm welcome from my side. This is the webinar How to Automate Your Materials Testing Processes. My name is Robert Kaifler, so I will be your host for the next, so to say, 30 minutes, 45 minutes, however it takes. What are we doing is we are presenting solutions for robotic testing and also the motivation why to do automatic testing. So that's coming up. Let's get into the topic. First, introduction of myself. My name is Robert Kaifler. I'm in projects and product management. So I'm in the automation department at ZwickRoell in Ulm. I'm working for ZwickRoell since more than 25 years, so pretty experienced. And I got experience of around about 300 automation projects, so all over the world, no matter if it's the Europe focus or Asian focus or America's focus. I did projects all over there. So yeah, that's my background. Therefore, I'd say let's start into the presentation. I'm going to switch off the camera of myself, but of course you still hear me and my voice. All right. What's the agenda? Introduction, that's what we already handled. And then we're turning into one of the main chapters. I call it automation, what you need to know. So this is a kind of pre-information surrounding automation, what we recommend to do, how to start with, and also here then automation myths versus facts. So that's something which is typically brought up, which is not speaking for automation, and that's something I like to point the first attention to. And then number 3 is then really the core part, solutions starting from 10 samples to test per day up to 500 samples per day. And the last section, number 4, is then Q&A, questions and answers. One more comment about the working environment here. So if you would like to raise up a question, feel free to do this. In this case, we got a chat or a questions section, which you see in your interface. So there it's a question mark pointed out, and there just write in the question, and then I'm going to be able to respond it to you. Typically, I can answer it instantly. If not, then we're going to do a follow-up. Yeah, so let's dive into the topic. Automation myths versus facts. What's the background here? There are a lot of myths surrounding this matter of this topic of automation. The myth number 1, and we got 6 of them. The myth number 1 is automation solves everything. So the background is here. Sometimes there's the rumor, hey, if we cannot cover a job, let's go for automation, and then everything is clear, checked, and we get rid of the problems. So definitely automation is not a magic bullet, and it will not solve quality or consistency problems. It will then make popping up more obviously, definitely, but it will not solve it. But if you're going to define clearly the needs and objectives, then that will lead you to efficiency, shorter cycle times, more consistency, higher quality. So this is the consequence, but not the first shot. Then the myth number 2 is, I don't want to have automation. Automation is too complicated. It really doesn't have to be. Why that? Because if you're gonna approach the whole automation thing with starting small and simple and then scale it afterwards, then it's a very easy thing to start with. So it's way better starting small and simple instead of really having a big, super large project. And in the meantime, and this is here the last topic. So I got a comment, no slides are visible. Let me quickly see. Share. Let me quickly. Maybe you can, those in the meeting, maybe you can just write a short comment whether they also got the problem that no slides are visible, because that would give me a clearer localization of the problem we may have. Because, okay, slides are visible to me. I see slide number 5, yeah, which is correct. So maybe, yeah, okay, thanks for the feedback. Seems that it is a local thing. Maybe those who cannot see it, maybe you're just going to rejoin the session, and then you're seeing it. Because thanks for responding. We are currently at slide number 5. So coming back, so I'm just going to go on. Those who cannot see, maybe you're just going to rejoin the session. I'm turning back to myth number 2. Automation is too complicated. So I was drawing the attention to the last point here. In the meantime, during the last years, we had the introduction of new user-friendly software tools. In our case, it's the AutoVision software, which is controlling the robotic system, and also the ZwickRoell teaching tool. So especially with that teaching tool, it is not necessary for the operator to program the robot at the robot interface. So you purely can handle that with the tools, the software tools from ZwickRoell. So at the end, automation does not necessarily need to be too complicated. Then the next slide, myth number 3. Automation will replace valued employees. That's a fear we are always confronted with. And at the end, if you look at the details, automation will replace tasks, not people. The objective of automation is automating processes that are monotonous, which means they are boring. They are dangerous, for example, heavy samples, or safety-wise, if I'm talking about syringes or cutting edges or so, it's dangerous, or it's unpleasant and dirty. So the objective of an automation is clearly data generation via automation and data analysis via the human being, the operator. That means generating the data is really the key with the automation. Then myth number 4. Why fix something that isn't broken? So I got a system, I got a project, I got a machine which is working. And at the end, it's a fair point. If there is no reason for abandoning reliable equipment, but on the other hand, why not integrating existing equipment? Means an existing tensile testing, impact testing, autoinjector, prefilled syringe testing machine. So that's at the end. That's a fair and reasonable point. So here our answer is, why not integrating existing equipment into new robotic system? So at the end, today's solutions are fast, flexible, and adaptable, means you can use really existing equipment. And then the last 2 myths versus facts. Number 5, we lack the in-house skills to program a robot. So there we got separate alternatives. The knowledge can come from within your company. So in the meantime, with the introduction of smart robots, we brought the whole thing down from, let's say, a higher level of robot knowledge down to a more common user interface. So everybody interested in programming a so-called smart robot today is able to do that. And a lot of young guys are willing to and are able to program such robots. That wasn't the case years ago, maybe 10, 15, 20 years ago. You were forced to contact a robot specialist mainly from the supplier or implementation company. And nowadays, there is the intuitive user interface. Means in our case, it's the AutoEdition teaching tool. So a software tool which we are supplying to you. In this case, it's free of charge for you to make the modification by yourself if you want. We know in the medical industry, modification is not so requested because they need a full traceability, they need an audit trail. So they want only a certain limited amount of operators or supervisors to be able to modify something. Myth number 6, automation is prohibitively expensive. There the answer is with a few slides later. I will get that topic. Buy equipment according to your needs, not overspecified. So at the end, look at the most common sample types which are coming up in your lab and try to find a solution for that. And then in the future, you may have the chance to grab another 10, 20% of the sample material with adapting or adding something to an existing system. And the focus is clearly on the total cost of ownership, means from A to Z for the whole life cycle. All right, what to focus on? So now we were coming from the myths versus the facts, what to focus on. So if you're doing an implementation of a robotic system, our experience is, I think I got 4 or 5 points, what to focus on. Focus on the digital transformation of the overall process. So at the end, the automation we are delivering is giving a certain idea, is giving a certain range of jobs to do. On the other hand, there are also parts of the whole process which are currently manual. So automation, yeah, everything is digital, okay. But also think of making the sample preparation, sample identification via to decode the sample, transport, post-processing analysis, make also that kind of stuff digital. So do not think always of the robotic system itself, but also the side processes like sample preparation and afterwards, after the testing, this post-processing. So again here, think big and start small. And the start small, that's really the key point. That was focus number 1. Focus number 2, counteracting staff shortage. What we will definitely have in the laboratories or working places, in the physical working places, we're going to have a shortage during the next years. No matter if it's now here, by 2030, there will be a shortage of up to 5 million skilled workers, or if it's 4, 3 million, or 6 million. The lab staff expects in the future modern digital working environment, for example, I don't know, 4-day week. Also to be able to have a home office, flexible working hours, for example, for bringing kids to kindergarten, having outside meeting with friends in the early evening. So attraction of a working place is a modern environment, and what the lab staff is expecting is such a modern interface. So the conclusion is, when people are not available, robots are able to step up. That means not that they will replace again, they will not replace the human beings. The robots need to be set to these monotonous works. That was number 2. Number 3, this is my personal favorite. Focus on the fact that only the material counts. So if you see on the right hand side, what is influencing the measurement result is the man, the operator, So the operator is influencing the measurement results. The machine is influencing the measurement results. And the material is influencing the measurement results. So at the end, what your boss, what your company would like to know is not how cool the ZwickRoell machine is. They do not want to know how cool the stuff, the man, the operator is. They want to have a clear statement about what the material as properties has, and therefore, and this is the green bullet, so to say, only the material counts. So your company wants to know really what kind of values the material has. So the parameters, the results. And the target we are following here is we need to focus on the material. And the target here is reduce man influence. You see here the points you can deal with to reduce man influence, like the digital process, partial automation, full automation. And reducing the machine influence, you already do this by calibration. Sometimes we have customers with daily checks, sample preparation, and also homogeneous test equipment. So that's the core of this sheet, of this slide. Reduce man influence and reduce machine influence. Why that? You only want to know what your material has as properties. Focus number 3. The last focus I'd like to draw your attention to is focus number 4, flexibility and being ready for the future. The challenge for us nowadays is we cannot predict what kind of samples, what kind of material we are testing next year, tomorrow, in 2 years or 5 years. That's something which changed during the last years. And therefore, it's important to be flexible. So if you're testing, like in this example here, 10 samples today and 100 samples tomorrow, it shouldn't give you a headache if 100 samples are coming in because the operators are in vacation, holidays, out for training. So this example, no problem with automation. The second dash point, let's imagine it's 4 p.m. and a colleague is stepping in saying, hey, I need to have a quick test of another 20 samples. And you think, oh my God, I need to pick up my kids from kindergarten. That's the flexibility we want to have with automation. So no problem with automation. And the good news is, and this is the last sentence and the conclusion, your ZwickRoell equipment is ready for future from day one. Means no matter what kind of equipment you're buying today, which kind of load frame, tools, and so on, up to 80% of the components you're having can be reused when expanding an existing machine with automation. So this is the good news. And again, I told about it, start small and then scale fast. Starting is the key point, and there we need to start in a very easy way. Now we come into the main section, solutions starting from 10 samples. So in the description, we were talking about solutions starting from 10 samples per day, which is not too much, but automation still makes sense up to, so to say, 500 samples per day. First, we did split up our whole product concept into 2 lines. On the left-hand side, there's something we're going to dive into right now, is the so-called standard application packages. So these are packages we defined according to the most common standards, which we have a packed solution in our store. And what we're going to do is we define these packages. We're going to take it out of our shelves, put the label on it, and send it directly to you. So it is a predefined package. This is the left-hand side. And on the right-hand side, this is the customization. So everything you want to do aside from this standard on the left-hand side, we have also customization. But first, let's go into standard application packages, which I frame green right now. What we have in here as a super compact system right now is our Alex. Alex we said this is the background is a example for an automatic lab assistant. So it's our brand new automation for low volume testing. What is our motivation? We want to provide a system, a robot, with accurate and comparable test results with minimum effort. And this is a new solution we released this year, beginning of this year. So it's really a brand new system. What it is consisting of, it is, you see the testing frame, and then you're gonna see some robot axis. So all of these black covered bulbs are the motors, and we got a compact magazine rack. So at the end, the space required for such a system is very similar for which space the operator needs. So at the end, the Alex, and this is the big benefit, Alex boosts productivity and reduces your cost per specimen. So at the end, what we are really claiming for here is new operators are trained within 1 hour. So at the end, even if a new colleague is stepping in, he can instantly do some tests, more or less. How is the system looking like? You see it on the left-hand side. This is a manual load frame. On the right-hand side, you're going to see this equipped with a Alex system. So at the end, it is not only sold as a totally brand new system, including a testing machine. Like I said before, this scaling, if you have an existing frame, Alex can easily be retrofitted, adapted, attached to this existing load frame. So it is compatible with the tabletop frames. There is no holes necessary. It is attached to this T-slot on the left-hand side of the machine. And you can even keep existing test expert programs and just add the auto-edition software for the automation. So this is a very good example. It's compact, quickly available, and you can add it to existing equipment. So I just recently had a case, it was this week or last week. A customer originally bought only a machine you can see on the left-hand side. And then he thought, maybe I'm going to need an automation too, because it definitely makes sense for me. So meanwhile, in this case, in this project, the machine was already in production. He additionally purchased a robotic system, and no worries about that. We're gonna include, as I said, it's already bundled in our shelves. We're gonna take out the Alex, and before delivery of the load frame, we're just gonna add the robotic system. So the good news is, even the customer did buy only the manual testing machine at the beginning. We can directly fulfill his wish after some weeks delivering not only the manual machine, of course, but also the robotic system. So here you see the difference, or the not difference. So the space required by the testing machine and the space required by the user, which is the top view of the user, and on the right-hand side, if it's the Alex dimensions. So it literally fits in every lab which is a testing machine placed at and an operator. So it's really super compact. What kind of packages did we define? We defined it for these application packages, this Alex for small and medium plastics compounders, for independent testing labs, for automotive plastic parts producers, for steel and rolling mills, and for R&D centers. So for all of these 1, 2, 3, 4, 5 different applications, the concept of Alex is made for. That was Alex. We're gonna have more standard packages. I just will show you an overview of regarding metals. It is the roboTest L system. It is working horse if you want to do really hardcore production testing on sheet metal. And we got the plastics package where you're going to do bending, flexure, or tensile test on PP material. How is it looking like? What is a roboTest N? A roboTest N is an add-on box, an add-on robotic system. You see here on the left-hand side, it is flexible and versatile. In the case of the plastics, it's for ISO 527 or the ASTM D638. Capacity is 30 pieces. We're gonna have a cross-section measurement station included and a disposal. And the user interface is quite flexible. So that's definitely not as compact as the Alex, but it also offers additional benefits with the cross-section measurement station. Cross-section measurement station, by the way, is also available for Alex, but the magazine rack is definitely larger in this case of the roboTest N standard package. The basic robot here is, you may have recognized it, is a UR robot. So it is from the manufacturer Universal Robots. We are using this brand since, I think, six to 8 years. So it is really, for us, it was a game changer regarding the robotics, because it brought this mysterious robotic experience down to a interested user level. So any interested user can work and even, let's say, adapt such a smart robot system like the UR robot, the roboTest N you're going to see in the picture. If you need more information, the standard packages got quick delivery time, so they are on stock, so you can more or less get them instantly. We got attractive pricing, and the spare part availability is more than 10 years. So you can scan the code here. We got on a web page extensive material. We can you can look at videos on ZwickRoell.tv. So plenty of information is available. Next package, this is now metals, roboTest L. L means we're gonna have here a linear axis, that's why it's called L. And we have a moving table as a second axis. So here the focus is clearly on working horse for metals testing. So the typical ISO 6892 and ASTM E8 are fully matching. We got here capacity of 160 samples, cross-section measurement, code reader, reduction in width, transversal strain, disposal, and so on. So it's that working horse for high volume testing of production in sheet metal, aluminium, or even round samples. Same here, plenty of information available, including a video. Also quick delivery times, more or less instantly, attractive pricing, spare part availability within 10 years. That was the standard packages we are providing. Now we're turning into the customization. And I just brought some examples with me, because customization is, it could be anything, could be nothing, could include the machine you have in your laboratory, like I said. And therefore, I just would like to have some examples pointed out. First, I brought with me one video. So this is, it seems at first instance, seems a standard roboTest N system. So again, we're having this UR robot, this universal robot. We call it roboTest N. And in this case, we are not covering only one test, like tensile or flexure, but we are covering 4 tests. How does it look like? First, we are having a look at the samples. So we are matching with the trouser piece, the flexure test, the tensile test on rubber, elastomer, and the tensile test on rigid PE/PP. Test number 1, PE/PP. So you see me feeding the robot. You place the magazine rack inside. Then you're going to start the robot. The user is selecting, presetting, hey, which test is done. Then we are making the cross-section measurement at 3 different positions. And once that is done, we are bringing the sample to the testing machine. So now you see in the machine, we are having the pneumatic grips and also the extensometer. That's the test right now in fast motion, but we focus on the automation. Then the test number 2, rubber. The material is different, it's soft. We are having here not a cross-section measurement station, but a thickness measurement station. So we are measuring purely the thickness of that soft material. The grips are the same, you see, the extensometer arms are the same. And again, this is right now, that's the tensile test on that rubber. Now, more interesting, this trouser piece, according to ISO 34, you see we are handling it also with a robot. We are measuring the thickness. And then we are bringing it directly into the testing machine to cover this trouser test. Then we're doing the tearing. You see the extensometer arms were removed. Last test, number 4, is the flexure test. So we are using here again the cross-section measurement station for this rigid material. And then in the meantime, in the background, you see we changed it to banding, to flexure. And again, we're using here extensometer for looking at the deflection. So this is a first customized example. This roboTest N do not have only 1 test covered, but 4 tests covered. Next example. This is a pretty extensive system. We supplied in this arrangement, in this configuration, 3 to 4 times during the last years. So what we're having here is a tensile testing machine. We're having a flexure testing machine, and we're having a robotic arm. In this case, it's a KUKA robot, and we're having the magazine racks, and we're having the cross-section measurement station. What you may miss here is the protection device. We made this picture without the protection device because with protection device, no chance to see anything of the testing machine and the different components. So of course, protection device is there, but in this case, we just left it away. So the core is here a 6-axis robot in the center, and that system really provides maximum flexibility. If you have simply moving axis, if one axis is moving just in X direction, then you are pretty limited with the movements that are available. But in this case, what you see here is we have the full flexibility of such a 6-axis robot arm. That was example number 2, roboTest R for plastics. Now we're turning to metals. This is a really massive system with a 1,200 kilonewton machine, and we're doing tensile test here. How is it looking like? This is a movie I brought with me. So we are having this heavy plates. The operator is loading the samples in the magazine rack. Then he's doing the programming or the setting the samples. Again, here the protection device was taken away for the movie. Then the robot arm is grabbing the first sample. We are centering the sample, that we are clearly in a defined position. And then we are placing it in the cross-section measurement station. And we're doing 3 measurements. Here, the customization is we are doing it with laser sensors at 3 different points. And once it's done, then we are bringing the machine, then we're bringing the sample to the machine. So the arm is coming and then feeding the sample to the testing machine. The blue light you see from the background is again the extensometer looking from the backside. And then the tensile test is more or less standard, and therefore it's in fast motion. And I can assure you, even if the pictures look like chewing gum, it was really a real metal or steel we were testing. That was an example about metals, heavy plate. Then I brought another sample with me. This is a so-called roboTest P. we're gonna have a portal system. That's why we call it P, like a portal. So it seems like a big door, a big portal. How does it work? Let's see how things are progressing. So again, here the operator is placing the samples and setting then the specimen office. So once done, the robot arm, the portal gripper, is gripping the sample. We are looking whether the presets of the operator regarding the sample length is matching with the real physical sample inside. Then we're going to do the centering of the sample in the parallel area. And in the next step, we are feeding it to the cross-section measurement station. And then we are measuring the cross-section again. That's standard at 3 different positions. So in this case, it's really some mechanical transducers. So you saw them attaching. And then we're bringing it to the testing machine. And the cool thing about such a system is you can use it with 2 machines. That's something which a roboTest R, a KUKA robot, can also do. But here, there is the option that you can place a second testing machine at the right-hand side of the configuration. And you can use 1 machine then for manual testing. And that's definitely a different story, because even if this robotic system has 2 machines, you can use 1 machine in manual mode and the other one in manual and 1 in automatic mode. So this is quite unique for such a system. Let's bring it back. So the example is here. You're going to have a testing machine here on the left-hand side. And if you would have a second testing machine on the right-hand side, you can use this on the left-hand side. You see in the picture still in automatic mode. And you can cut out the machine, not in the picture right now, but if you imagine there would be a second testing machine, you can use the second testing machine in manual mode. And this is really an exceptional key point. Even if you have 2 machines in such a system running automatic, 2 machines running automatic, you can cut out one if you want to, for whatever kind of reason, cut out one, saying, hey, this is now my manual testing, and the other testing machine is running fully automatic. Due to safety reasons, that's only working with such a portal system, so that's a big benefit of such a portal system. Okay, let's see whether there is one more example. Yes, now we're turning into medical. Medical is a very, very important industry for us. It grew dramatically during the last 3 years. And based on our roboTest N, the UR robot we have in here, we are testing different kind of medical devices. So it's safety systems, and you're going to see the values which are we are determining. So we are with the safety systems, we are doing the determination of the cap removal force, brake loose gliding force, and so on. So we are testing with such a robot, including a testing machine. We are testing the safety systems. Then we got other combinations testing pens, which means dial-up pens. We are testing autoinjectors. Again, you're going to see here the typical values like cap removal, actuation force, injection force, and so on. And the last here is the syringes or cartridges. So we're also testing them automatically, but every automation for applications you see on this sheet here is based on a roboTest N, on a smart robot, on a universal robot. How it is looking like? It's like in the picture you see. So there is the auto-injector tester. You do not see clearly as it's in the background here. In the front, there is the robotic system. The testing machine is running with TestExpert 3 software, and the automation is running with AutoEdition 3 software. So the AutoEdition is the control, but this is how it's looking like. And in real life, brought a last video right now with me. This is the robotic testing system for autoinjectors and safety systems, how it is running, how it's operated. We are bringing the REC, in this kind device 1, functional test on autoinjectors. We are starting the test, and we are grabbing the samples. So the robot is having, in this case, literally purely pick and place job. So he's picking the sample, placing it in the tester. Then now it's fast motion, as the focus of this movie is on the automation. So it's the functional test on this auto-injector. In this case, it's the Ipsomate pen. You may have recognized it. So we are checking the needle shield, and then we are picking the device from the tester, placing it back in the magazine. With the same robot, we are also able to test the other device, which is safety syringe device, SSD, or needle safety device, however you want to call it. So here we also have the robot arm using those carriers to bring in the needle safety device. Here again, the functional test in time lapse. And then we're going to place it back at the same position in the tray. And the last section of this movie is here manual testing. So if you want, you can also do manual testing. You just slide away the robot. Then you're gonna enter this safety syringe device and test it manually. So that's still an option, even if you're using all of our robotic systems. Manual testing is still possible. This gives you the chance to use this also in manual test for special applications or special tests which are instantly necessary. So what's the summary of all? So we're coming to an end. Oh no, brought the last example with me. Sorry, forgot it. This is the testing of break loose gliding force. Here we're having the prefilled syringes. So we are picking out the sample here. We are then moving towards the cap removal. So we are removing the cap. And then we are gripping it and bringing it to the ZwickRoell, to the testing frame, for doing really this break loose gliding force test. If you're in the medical sector, you know what we're doing here. And below there is the beaker collecting the liquid, collecting the drug. And we have two trays. One is maybe for in, the other one is for out, or both are trays to be tested. So that's the example for roboTest N, universal robot for break loose gliding force. Okay, what is the summary of this presentation? The main objective of automation is to boost productivity, which means we want to get more productive. So we did see solutions for 10 samples like the Alex, but also for 160 samples per day, or with this robot arm, this roboTest P or KUKA robot, you can go up to 500 samples per day. We did see solutions for medical, we did see solutions for plastics, and we did see solutions for metal. My essential point where you should focus on, apart from the automation itself, look at the digital process. Consider really the colleague robot for taking over this boring jobs, this monotonous, this dangerous jobs. Then, number 4, only your material counts, and consider the flexibility and being ready for the future. And of course, we know if you're going to ask for an investment into a robotic system, if you're going to ask your boss, your internal business model is always based on return on investment. And the goal is, again, on your side, boost productivity with sustainable efficiency. That's the target. So thanks a lot for participating. If you want to get more infos about it, just approach me or your local sales partner, or just any kind of email you find from ZwickRoell. Write us and we will respond to you. Thanks for attending. Have a good day.